to BC, so that's pretty exciting. It's nice to see your campus and how beautiful it is, and really grateful to Phil and Heather for arranging this and making it possible. We're always really excited to tell stories about our projects because even though it's been a few years now since I was a student and getting to be more all the time, I always really found value in understanding why the things that we learn in our classes actually matter and why we should be thinking about these things. And so I hope that that's an opportunity for you all today to see how a bunch of different disciplines or courses that you are studying or you will be studying come together when we think about these projects and these problems and how to solve them. So with that, I'm gonna dive right in to the Aral Sea Crisis. This photo that you see up here is an image of the ship graveyard in Moynock, which is the former port city of the Aral Sea in the autonomous region of Ecological, Pakistan, which is a part of Uzbekistan. And that's where we're going to spend the entire presentation, for the most part, is in Ecological, Pakistan. So what they've done at the ship graveyard, this is the former port, is they've arranged these ships and built a sidewalk around them as a form of like new tourism to try and draw people to see this ecological disaster and what's happening in this area. And there's a really cool museum. I have some photos of some of the art that's up in that museum. It's pretty incredible to see all these paintings of these seascapes like you would see, not unlike the Northeast, these old oil paintings of seascapes, and you're standing there in this museum and looking out over this, you know, desert area. It's a pretty wild contrast.
So are those ships?
Those are the ships, yeah.
Wow.
Those are the ships, and that's where you used to stand on this this bluff that I'm standing on to take the picture, and you used to look out over the sea.
So like, how long roughly would those ships be?
So I was telling Margaret earlier, they're huge boats. These are like old, huge fishing vessels. This whole area all depended on fishing. So, you know, a person would be about the size of this one of these little scrub bushes down here. So they're enormous fishing vessels. Yeah. So a little bit of background on TIFO first, before we dive into the Aral Sea, just so you all know where I'm coming from, and Ian and Margaret are coming from, and Phil as well as our board member. We're an organization that works to safeguard environmental health, and we do that largely through education and workforce development. And what we do is we really support leadership to catalyze change. We engage in a lot of knowledge sharing. So we don't go to a place to tell people what the problem is and tell them what they should do about it. We work with a community that has an interest in developing a collaboration to solve a problem and learn from each other and figure out how to solve it together. And that's a really important piece of what we do. We often say that the science is the easy part in our projects. It's figuring out how to solve them in a way that works for everybody involved, but actually is often the biggest challenge. To do that, we have to build really sustainable and meaningful partnerships. We often engage students in our projects, and I'll talk a little bit about that at the very end too. We have projects right now in Uzbekistan, but also in Kyrgyzstan and on the Duck Valley Indian Reservation, which is in Idaho, southern Idaho, northern Nevada. So what we're going to do today, this is another image of that ship graveyard. You can see some kids playing. These are some of the smaller boats that are in the graveyard. We're going to talk a little bit about geopolitics, because it's really important for understanding how this disaster happened. Then we're going to talk about what the disaster has done to this area. And I'm going to go through a literature review. And the reason I'm going to do that is so that you understand the process by which we approach these projects. We have to go in and find out all the information that's already been collected. I'm going to give you a summary of what that looks like. I'll show you what we did this spring for sampling in the area to try and understand what some of the environmental health risks are. And then we'll go through a few of the results on those. And we'll end with just a quick look at why this matters for the world. And then we'll jump into some questions and some discussion. Come on in, folks, don't be shy.
Pizza.
Pizza, get some pizza. Okay, do a little bit of geography lessons here. So Uzbekistan is highlighted in red there in Central Asia. And this is a zoom in on Central Asia. So you can see Kazakhstan is the largest country. Uzbekistan is actually in purple. And you can see between Kazakhstan and Uzbekistan, there's this area that has a lot of water on it. This is an old map. There's a lot less water in this region now. And if we were to zoom in on Uzbekistan, you can see Ecological, Pakistan. So Ecological, Pakistan is a semi-autonomous region. They have their own constitution, their own government, their own culture, their own language. They are the Ecological Pak people. They do not consider themselves to be Uzbek people. Karakopakstan makes up about a third of Uzbekistan in terms of land mass, but about a tenth of the population. It's very sparsely populated. And in fact, most of the population is really centered along the river that runs right along this border, and it used to run up to where the Aral Sea is. And depending on how good your eyes are, you can see on this map here where the outline of the formal Aral Sea is. And I'm going to show you a picture of that, but this is what it remains today. Karakopakstan, I think I said, third of the landmass, 7% of the population. This is a largely agricultural economy. It used to be a lot of fishing. Now it's a lot of mostly cotton, but also other agricultural products. This used to be the crossroads of the Silk Road. One of the Silk Road routes came right through Nukus, which is the capital of Karakopakstan. And Karakopakstan is, along with some regions of Kazakhstan, is the most impacted by the Aral Sea Crisis by far, economically, socially, ecologically, and in terms of health outcomes. Why there's an autonomous region there? Karakopakstan, has anyone here heard of the Soviet Union? A couple folks, some nods. When the USSR, the Soviet Republic, broke up, Karakopakstan was given independence at that time. And they really were recognized as a separate ethnic group and given some autonomy. But in the Uzbek constitution, it says, if this country ever wants to secede, they can. They're allowed to by vote. So it's really important to recognize that. They're entirely self-governed. And there's always been tensions between the Karakopak and Uzbek government, and that came to a flare just a little over a year ago. There were violent protests because the Uzbek president proposed taking that constitutional amendment out where Karakopakstan could secede. Huge protests resulted, they ended up not doing it, but constant friction between those two governments. A little bit of more contemporary political context. The tenure of the first president, right around 1991 when the Soviet Union collapsed. What happened during that time is that that president, pretty quickly after the Soviet Union collapsed, decided that Uzbekistan should be free of any outside influence of any kind, and forced a lot of external NGOs out of the country, including the United Nations. So in the late 90s, people were starting to realize what was happening in the Aral Sea and what a problem it was. And up until about the year 2000, there was a lot of research being generated about the scope and the scale of the problem. And then when all of the international organizations were kicked out, that research stopped. And people working within the country were not allowed to publish any of their research as part of this issue as well. So when we went into this project, we went into it without knowing anything more recent than about the year 2003. It was the last study that was really published in this area. So we've got a 20-year gap in information. In 2016, the reason that we were able to start working here was two things. One, MSF, Doctors Without Borders, was one of the few organizations not kicked out of the country. They stayed through this whole period to treat multi-drug resistant tuberculosis. In 2016, a new president came into power because the old president died suddenly. The former president died suddenly. And this new president has been a lot more open to partnering, to bringing in outside organizations. And so as political tensions are starting to thaw, Doctors Without Borders, who've been working in this area for a long time, saw an opportunity to bring people in to try and investigate what some of these environmental health risks would be. And I'll show you a little bit more about that partnership in a moment. The Aral Sea used to be the fourth largest inland body of water in the world. It was fed by two rivers, the Amu Darya and the Sur Darya. The Amu Darya is the one that flows mostly through Uzbekistan and to the port that I showed you a picture of earlier. So we're going to talk more about the Amu Darya River today. The Sur Darya comes around and goes through Kazakhstan, kind of comes in from the north side. More than 80% of Karakopakstan had been involved in fishing at one time. And it probably amounted to roughly 50% of the total income of the country. In the 1960s, what happened is the Soviet Union decided to divert the rivers that flowed into the Aral Sea, both of the rivers. The reason they did this is because they wanted their own source of cotton to clothe the Soviet army. They wanted to be able to have not be dependent on outside countries to get their cotton. They said, we know where we have a lot of land, we know where we have a lot of water, we'll just divert that river and use it to irrigate cotton. Cotton, as it turns out, needs a lot of water. It's really hard to grow it in the desert, especially. So a lot of water had to be diverted for this. It's also very pesticide intensive to grow. And when you harvest cotton, typically a defoliant is used, which basically kills the plant and causes all the leaves to shrivel up and die, and the pods to open up and the cotton to be released. So you have to use a ton of chemicals on this product. A lot of chemicals, a lot of inefficiencies, a lot of water loss. It didn't take long before the Amu Darya and Sur Darya rivers stopped reaching the Aral Sea entirely. So this is what that looks like. Satellite imagery from NASA from 1977 until this year. You can see the dramatic reduction over time in the surface area of this body of water. So when it first started reducing in 1999, you can see they started calling it the North and the South Aral Sea. And then they had to start saying, okay, by the year 2006, we've got the North Aral Sea and we've got the East and the West Aral Sea. And then the East Aral Sea completely dried up. So what we're left with is that tiny little sliver in 2003, that tiny little sliver on the left, and a little bit in the north. And they've actually been able to get a little bit more water in the north because they dammed up part of the area to the south to keep the water from moving anymore. So they've been able to recover a little bit more in the north. And you can kind of see that between some of these photos here. So I mentioned the Amu Darya and Sur Darya rivers. This is the Amu Darya River, and this map is really showing the amount of water that flows in from different points into the basin that flows into the sea. You can see a couple things in this map. One, there's a lot of countries involved. And I know these borders are really tricky, so I put a map in the upper right-hand corner so you can see it without the rivers overlapping. There's a lot of countries involved in the Aral Sea Crisis when you think about the inputs to going in. And the water is diverted throughout this catchment basin. It's not just Uzbekistan where water was diverted, because when they were part of the Soviet Union at this time, all those countries were the same country, right? So it didn't matter where the diversions were happening. The Uzbekistan of importance is really the breadbasket for Central Asia, and that's because it has the Fergana Valley, which is a really agriculturally rich area. So they grow a lot of the food for the rest of the region. Despite that, there's really no legal framework between all these countries for water sharing. Some countries have agreements with one other country, so there's those kinds of agreements, but there's no comprehensive agreement on how this works. And there's been a lot of PhDs done on the water conflict in Central Asia. I'm only going to give it a slide, but it's a fascinating area to look into. There's also a lot of yearly and seasonal decreases in water over time now because of climate change. So as Phil mentioned earlier, this is really a climate change problem as much as it is a geopolitical and water use issue. So how did TIFO, a tiny organization from northern Idaho, end up in Ecological, Pakistan? We work a lot with Doctors Without Borders. This is our 4th project with them. And I mentioned before, they were one of the few NGOs that didn't get kicked out of the country when outsiders were asked to leave in the late 90s. They kept staying there. They worked on MDR, multi-drug resistant tuberculosis, for more than 20 years. And they were increasingly seeing what they thought were probably health issues related to the environment. No idea specifically what that might be due to. There's a lot of possibilities. I'm going to go into those. So what they did when things started to open up a little bit is they reached out to TIFO and they said, what do you think about coming and working with us in the Ministry of Health of Ecological, Pakistan, and trying to figure out what might be contributing to what we think are increased issues related to health in this region. And what we do is we go in and we first look at all the available information, and that includes working with MOH, the Ministry of Health, to figure out what kind of monitoring and health data they have, and really digging into their data sets to see what there is available that they've already done, as well as looking at the available literature. And I told you earlier, there's really nothing after 2003. From there, we do a preliminary assessment, and that helps us to identify additional information we might need. I'm going to show you results from that assessment, really rough general results from that assessment in a moment here. And then we develop interventions that are targeted really towards improving health outcomes. We're a funny NGO in that we work at this intersection of public health and environmental issues. So we look at the things in the environment that really cause people to get sick. And the best way to reduce disease related to environmental issues is to stop exposures. And that's what almost all of our projects focus on, is figuring out how you reduce those exposures. So a little bit on the literature review, what we found. We know that the Aral Sea used to really stabilize that climate, and that now there's a lot more extremes in the climate. So it's a lot colder in the winter, it's a lot hotter in the summer as a result. They have dust storms more than 90 days a year now. And there's an estimate from a long time ago that over 100 million tons of dust had been deposited across thousands of miles from the bottom of what used to be the seabed. There's real salinization issues. And I'm going to show you some results from our soil and water sampling there. The groundwater typically exceeds World Health Organization guidelines by up to 4 times, and that's older data. And of course, we knew that there were a lot of pesticides that were used. So as an example, for DDT, in the US, we used to apply about 1.6 kilograms per hectare of DDT to crops. Uzbekistan was using a rate of about 54, and Pakistan was using a rate of about 72. So really high application rates of DDT. DDT is the book that Phil mentioned earlier, Silent Spring. That's the pesticide that has been banned in most of the world now, including in Pakistan. These are old numbers. They don't use it anymore. And of course, massive biodiversity loss has resulted too. When your sea dries up to be 10% of its original size, there are mass extinctions that occur. We looked at water quality information. We found there was high levels of persistent organic and inorganic pollutants. That includes things like nitrogen, which is obviously used as fertilizer, along with phosphorus, as well as pesticides and other compounds. We found that in the available time we could look at the data, the water quality appeared to be getting worse and worse and worse until the data stopped. And we knew that there had been some routine monitoring by the local health departments. Dust. Ella looked at PM 2.5 data for her research project, right? Everyone here knows about PM 2.5. If you didn't before, you do now, because it got really bad with the Canadian wildfires this year around here, right? We're used to this out in the West. Like PM 2.5 is something we know about. We live with it every summer, and I think the East Coast now understands what that means in a very real way. But back in 1995, people were focused on PM 10. We weren't looking at those small particles yet. So a lot of the old data really focuses on PM 10. So we didn't really have any good data to tell us what the air quality risks might be. We didn't find much info on linking air quality to health effects. We couldn't, there's 2 possibilities there. There's a possibility of physical damage, of just inhaling particles that can cause damage to your lungs. And of course there's risk depending on which kind of chemicals are in those particles, because those can cause different types of toxicity, right? So if there's pesticides, as an example, which we know that there are, our concern is that then there could be some other toxicities going on. One of the most interesting sets of studies we found were on food chain contamination. This was one of the last studies to be published, interestingly. And it was done by Ecological researchers along with WHO and some other organizations. And they found long-lasting organochlorine pesticides, which are highly toxic and highly persistent, mostly in animal products. They found it in some vegetable oils as well, but it was highly concentrated in a lot of animal tissues. They found high PCBs in fish. And the most concerning, possibly, is the fact that they were finding a lot of dioxin in sheep and fat and dairy and eggs. And they found some in cord blood and breast milk as well. So we knew it was getting into people, which is especially concerning. And when WHO looked at this, the dioxin levels far exceeded their recommended values for health risks. So again, I gave you a hint on this. Persistent organic pollutants, they ended up finding those earlier in 1997 in cord blood. Those first 2, HCV and HCH, those are byproducts of a pesticide called lindane, which is no longer used, it's banned. It was used a lot at the time. They also found DDT in one of its byproducts, DDE, in the plasma in the blood of pregnant women. And of course, those pesticides are all banned and restricted in most countries in the world, including now in Uzbekistan. There was some evidence of elevated rates of non-communicable disease, NCD. And there was the anecdotal evidence that this exceeded the rates in other regional countries from the former USSR. And of course, we always are worrying most in these sites about children's health. Because when we talk about environmental health risks, children are the most vulnerable and they are the most susceptible. And that's because they get a bigger dose per body weight. It's also because they're still developing, especially their brains and their other organs are still developing. So when you get an exposure to a dioxin or a lindane byproduct as a kid, that's far more dangerous than it is for an adult for a lot of reasons. And so the concern here is that what that means for children and what that will mean for them into adulthood. I mentioned that we looked as much as we could at the health data provided by the Ministry of Health, which includes environmental sampling as well as some tracking of disease rates. It's very limited. They don't have a digitized database, so you have to go through the old paper records. And the paper records are housed in each sort of county. So you have to go to each county and flip through the paper records and see what it was. So it's nearly impossible to have an understanding of what regions might have higher health issues than other regions and what those health issues are. So why did I tell you about all that? Well, of course you have to do a literature review to try and understand the problem. And we had some interesting results that we were able to find. But again, if you think about the data we had, which were about from the 1999 period, and if you think about what the Aral Sea looks like today, it's pretty different. So you know the situation has changed. You know that the agricultural practices have changed. We're using different agricultural chemicals now than they were 20 years ago. So at this point, you know you have to go in and do new sampling, right? To develop a new database and try and understand what some of those issues might be. So we went in to Ecological, Pakistan about this time last year, and then again in March of 2023. And we were able to sample soil, sediment, water, and air. It's a good starting place. Food sampling is really expensive and really hard, so you generally save that for when you know exactly what you want to target and where. Biological sampling, really expensive, really hard, and when we start testing people, it gets a lot more complicated, right? So we really want to focus on some of the simple things to start and see where that would take us. And how we did this is we did it by zone. So we have that image of Ecological, Pakistan outlined in red here. This is an image from Google Earth. And we split the populated area of Ecological, Pakistan into 6 zones. Very few settlements out here in the deserts, very few. Most of the ones that are out there are for oil and gas drilling, and they're very small and itinerant. So we wanted to focus on where the kids and the pregnant women would be spending their time. That's in these regions, which runs, of course, along the Amu Darya River. It's all these irrigated lands, right up to what used to be the Aral Sea. We did a lot of work in 4 weeks. We installed a weather station in the capital city of Nukus. We installed 3 purple air particulate monitors to get PM 2.5 data, which anyone can jump on their phones right now and look at. We collected 30 passive air samplers, badges that people wore to see what kind of chemicals might be in the air. 23 sediment samples, 68 soil samples, and 82 water samples from 80 distinct sites around the country. We did a lot of work in just a couple weeks. We split those samples between 4 different labs, and we do that for a couple reasons. We want to, as much as possible, use the local labs, support local institutions, keep costs low. But there's certain laboratories that are better at analyzing things than others, and so we had to try and figure out how to keep our costs low while still getting data that we could rely on and help understand the risks. So we ended up using a lab in 2 labs in Ecological, Pakistan, actually, and then a lab in Tashkent, and then New York is where the passive samplers are going to Yale University, as well as a lab we have in Northern Idaho for soil. I use the word we a lot in this presentation. We is not just TIFO. We is MSF and the Ministry of Health of Ecological, Pakistan. We're also working on bringing in some collaborations with one of the universities there as well, with the Ecological Pak Medical Institute and Ecological Pak State University. So we is not just TIFO. That's something I should have pointed out earlier. Ian especially spent a lot of time with the local labs in Ecological, Pakistan, trying to figure out what kind of analytical capacity they had, what kind of equipment they were running, and what they had been focusing on when they were analyzing samples from the region. We also had a lot of conversations with folks about what kind of agricultural chemicals are currently in use. And I'll show you, we talked to farmers about what they use. We went to shops that are selling pesticides. We took pictures at markets, and we learned from the local agricultural agencies as well. So a couple pictures to help you guys understand the sampling. The picture on the left, there's two men, and they're each wearing a little tiny red badge. It's probably hard to see, but I circled them. Those are the passive air samplers. There's just these little magnetic clips. We had people wear them for about 3 to 5 days each. That's why we worked in one zone at a time, so we could get an air sample that kind of represented one region, and then put it in a glass jar, pop it in the freezer, move to the next zone, put on another sampler. The weather station that was installed in Nukus, so that's now, there's a weather underground location for Nukus, Ecological, Pakistan. So we can go on and validate our particulate data with weather data and the weather station is pulling in. And then on the right is our then student intern, Brock, standing right below the purple air monitor that we installed at one of the Ministry of Health rayon offices. I'm trying to, it's like a district or county is the word I was looking for. So we installed those at 3 different counties, and Brock is standing at one of them at the MOH office there. And of course, duct tape. You always have to have duct tape. Water sampling. We collected water from a lot of different types of sources. So the photo on the left is showing you an irrigation canal, water that's diverted from the Amu Darya River, sometimes traveling hundreds of kilometers in that open canal. So you can think about if it's 100 degrees, 120 degrees during the day, how much evaporation there is off that canal, and how much seepage there is into the soil, to go to different types of agricultural lands, mostly cotton. The picture in the middle is really important. This is a picture of a community well. Most of the population is on municipal water in the cities and the towns, but not everybody gets their water that way. And even in places where they do, the water sometimes only runs 5 hours a day, 8 hours a day. So what you see in a lot of these communities, especially in agricultural areas, is they've gone out and pulled together money and installed a small well. The aquifer is actually about 400 feet or more below the surface. They can't access that with a hand dug well. But what they do is they install these wells right next to these irrigation canals. And they only have to be about 10 to 30 feet deep. And really what that is a purged aquifer that's created from the irrigation canal leaching into the surrounding water. So this is one of those locally made hand pump wells. We sampled a lot of those. And then we sampled municipal water supplies. So on the far right is a picture of Jerry collecting a water sample from a canal where the intake is to be treated to go into the municipal water supply. We collected sediment, so again on the left, irrigation canal. In the middle, that's an intake from one of the municipal water supplies, collecting a sediment from there. And then that right photo is just showing you kind of how we do it. Sediment sampling is kind of easy because you know it's always mixed constantly, so you don't have to do a whole lot of homogenizing yourself. We sampled a lot of soil. And we did this in agricultural areas as well, but the photos I have up here are from playgrounds and schools. I told you earlier that kids are a lot more susceptible to environmental health risks, and that's why we always try and sample at areas where kids are spending a lot of time. And these places are great because they're public areas that we have access to because we're working so closely with the state government, so we don't have to go into somebody's home or into their own backyard. We can go to a school or a playground, a place where the government has the authority to go in and do the sampling. And what Brock is holding in the right hand, in the left hand picture, excuse me, he's pointing something at the ground. That's called an X-ray fluorescence spectrometer. That's a handheld device. It's something we rely on a lot in mining sites because it tells us about heavy metals in soils. And it'll tell us the concentration of heavy metals in soils within 60 to 120 seconds. It's a great screening tool. Better for some metals than others. It's great for lead. It's pretty good for mercury, pretty good for arsenic. And a good screening tool for other metals to say, like, yes, you should come here and collect a sample depending on the result, or maybe the result isn't very high, it doesn't look like it exceeds a US standard, not a place where we need to collect a sample and send it to the lab and spend a couple $100 to get the same data. So we use that a lot, and what we learned from the XRF is there's really not a heavy metal problem in Caracal-Paxton that we can find, at least not in most sites. There's probably in industrial sites, but we're really focusing on community health risks. I mentioned that we sampled in commercial and agricultural fields. The photo on the left is actually one of our MOH environmental health technicians that we worked with. She's actually in the sampling in the seabed. This is in the former Aral Sea, and we dug, well, actually our driver refused to let women dig holes, so he dug the holes, and then we got to go in and sample dirt from those holes. Jerry in the middle is doing it in a commercial agricultural field, and then in the right, we have a home garden. People grow a lot of vegetables in their backyards. It's really important to people to have their own source of produce. And in areas where they have enough water, which is the farther south areas of Caracal-Paxton, people will grow their own home produce. You don't see that as much in the north because they just don't have enough irrigation water up there. So then we get to the analyses. We screened these samples, we screened the water, soil, and sediment for pesticides, and then found some elevated levels of aldrin, heptachlor, and DDT and its byproducts, and lindane and its byproducts. We looked at soil quality parameters, especially salts, because we know that salinization is a massive issue in this region. And because we were using a local agricultural government agency lab, they also did a lot of analyses on soil productivity, so humic content, bicarbonate, the amount of nutrients in the soil to support crops. And then we looked at water quality parameters, including salts and turbidity and dissolved oxygen. And those are all important when we think about the pesticides in the water, and I can dive into that later if we have time. We don't have data from our passive samplers yet. We haven't gotten that back from Yale. But we do have purple air data that I'm going to show you in a minute from those PM stations. And I'm going to show you what we learned from those farmers and those agricultural chemical shops. This is the Purple Air Network. It's a screenshot I took just a couple days ago. It's pretty incredible, the amount of data there is. And these sensors don't just give PM 2.5 data. You can go down to PM 0.3 or all the way up to PM 10. You can get temperature and humidity. You can get air quality index based on the EPA air quality standards.
I bet a lot of people in here don't know what purple air is.
Thank you. So purple air is just the name of, it's just the manufacturer of the monitor. It's just the brand name. Thanks, Phil.
It's citizen science.
It is citizen science, absolutely. It's pretty cool because you can just buy one offline for $300 and install it and link it to Wi-Fi and you've got data. So then when you zoom in a little bit, I'm showing you Uzbekistan right here. We've got the first 3 air quality monitors in Uzbekistan. Right next, this one down here, or in Caracal-Paxton, excuse me. There's one down here in Uzbekistan as well. But these 3 dots are our PM 2.5 monitors up and running. And we go in and download the data every 2 weeks so that we're building a database of results that we then can analyze and see what kind of air quality risks we're looking at. This is an example of some of the data you can get off of those monitors. So at the time when I pulled this down in Nukus, the PM particulate matter 2.5 air quality index was 53, which is considered to be moderately hazardous if you're somebody who has pre-existing health conditions. That's just a snapshot. And you can see here, it tells you what it is right now, the 10-minute average, the 30-minute average, and I have pulled up right there the 6-hour average as an example. So you can get a lot of data out of these. What do we learn about agriculture? We learned that all of the fields that are used for ag have to be flooded before they are planted, and sometimes throughout the growing season. The reason they flood the fields is because they're so salty. They have to wash the salt away in order to get anything to grow. So if they can, they'll do it 3 times a year if they have enough access to irrigation water. They have to throw a ton of fertilizer back on that soil because they just washed away a lot of the nutrients when they flooded the soil. They no longer use DDT or lindane or some of the more pervasive defoliants, but those are persistent organic pollutants, POPs, so their byproducts are definitely still in the soils. The pesticides that are used today, we got a lot of information on. Most of them tend to break down within 2 to 3 weeks, so you have to sample right at the time of application to capture them. The reason we would want to know what those are is for occupational health and safety risks. A lot of women work in the fields, especially in the cotton fields, so that is something we want to know about, because childbearing women, or women of childbearing age in general, of course, are high risk for exposures. I'm just going to play this little video for you here. This is driving by some of the flooded fields when we were there in March. There's an irrigation canal. And we get into the housing areas, but I think at the beginning
It looks a lot more lush than I would have imagined.
You know, Phil, that's a great point, and I'm glad you brought it up. It's lush when you're right next to the river, because they're irrigating all of that. And as soon, we went up onto a plateau at one point, and as soon as you get up onto a high area, it's amazing, because you see the green and you see where the agriculture stops, and it's just desert, just brown. It's really wild to see what a little human hubris can do, right? For our water samples, all 50 water samples we collected exceeded at least one regional screening level. That's a US term for something that means a concentration at which more investigation is needed, right? So it's not an enforceable standard, but it's a standard at which somebody says in the health department, we've got some kind of issue here, we need to follow it up. So in all 50 samples sent to the Tashkent lab, there was at least one exceedance for a byproduct of lindane, a byproduct of DDT, or some of the newer chemicals like heptachlor. We found really high salinity levels. They weren't quite as bad in those municipal city water supplies. That's probably because of some of the settling and filtration they do. They were really high in shallow wells, and of course in surface water coming right off the Almudaria, and in the irrigation canals it was quite high. We recognize that the time of year that we collect those samples is important, because it really just depends on what's happening in terms of agriculture and runoff from the mountains down south, but up in Kyrgyzstan, right? Because the mountains are to the south, so depending on what kind of runoff we're seeing. We're working still on our geospatial analyses of all our water results. We haven't been able to identify any immediate patterns in terms of what we found, and that's largely because of, like I said, the time of year we were there and when these different pesticides are being applied. Soil results, we found aldrin and heptachlor in soils. We found a few other pesticides as well. And we recognize again that the timing is really important. We were there early in the planting season. People are probably going to be applying pesticides a little bit later in the year as well. We did find that salinity concentrations kind of seem to increase as you go north. So this is the southern part where we sampled, circles being soils and triangles being sediments. As you move north towards Moynock, towards where the Aral Sea used to be, it seems to get worse. But again, it depends on how recently they flooded their fields, right? So a lot of this kind of is caveated by which kinds of samples we collected and how recently those fields have been flooded. Why do I keep talking about all these chemicals? DDT and its byproducts we know to be neurotoxic. We know that it impacts the liver. We know it's a reproductive toxin. And we know that it's a probable human carcinogen. Lindane, with long exposures to lindane, neurotoxic, liver and kidney toxins, definitely carcinogenic. It's a known human carcinogen. Heptachlor is a developmental and reproductive toxicant, also possibly carcinogenic. We know that aldrin and dieldrin, again, neurotoxins, liver, kidneys, and reproductive toxicities. Every single one of those. When you see the word neurotoxic and developmental toxins, think about kids and those developing brains and what that means for those kiddos. Water salinity is a new one to us because we tend to work in areas where we have contaminants, not necessarily this kind of contaminant though. If you drink water that has elevated level of salts for a long time, and this isn't salt that you can necessarily taste, although sometimes the water quality is bad enough that you can. It can lead to all sorts of problems in the long term with chronic exposure. That includes heart disease, stomach issues, kidney disease. The other problem is that high levels of salt and dissolved solids in the water samples can actually magnify what happens to pesticides in those samples. We know there's pesticides in there, and so this could be exacerbating some of those other issues. Ultimately, there's still a lot we don't know. But again, this is a preliminary assessment, so it gives us some things to follow up on with our partners. We know that we couldn't really quantify the risks at this point because it depends on a lot of unknowns still. We don't know how frequently people are exposed. We don't know the severity of those exposures. We have one time point that we can work with, but we don't know if that severity is the same throughout a year or throughout a lifetime. We do know, though, that kids are of greatest concern, including in utero exposures, exposures to women, and worker exposures are also a concern. So I'm going to show you a little video here. This is driving by a cotton field as it's being picked, and you can see all the people working out in those fields picking cotton. And more than 90% of them are women, right? These issues are all exacerbated by health issues that we see in the area, including malnutrition. I think the anemia rate is more than 90% in adult women in Karakalpakstan. Suppressed immune function would also be a major risk factor, and if you think about tuberculosis and other comorbidities, and how that might exacerbate some of these chemical exposures. So from here, we summarized all the data, and we made some recommendations, and we're gonna go to Karakalpakstan in like 3 weeks and talk it over with our partners. So our recommendations are: one, it shouldn't be a surprise that we really need to identify and support vulnerable and neglected populations and fully characterize what those exposures might be for those really specific groups. There might be an opportunity to do some occupational health and safety training to protect workers, and potentially some nutritional supplementation, especially with those anemia rates, and hopefully working with some bigger agencies on provision of safe water. We want to develop a comprehensive water quality assessment project, and we'd like to do that in collaboration with local agencies as well as local university researchers, because there's been a lot of great research done in the past few years. And we could do that, and if we could digitize some of their monitoring data and go back in and analyze some of those trends, that would be fantastic. Just get all those paper copies and start entering them into an Excel spreadsheet, right? Start making a plan to digitize a database. And then, of course, supporting monitoring programs in the area. So that includes the work that's already being done by the local agencies. They're going out and collecting soil and water samples occasionally. How we can help them, figuring out how we can help them to update some of those practices and make sure that that data is actually something that can be used into the future. Figure out the types and application rates of some of the herbicides and pesticides we learned about, and see what kind of fluctuations there are in the contaminants that we identified and how that varies seasonally and over several years. So before I wrap up, we have plenty of time for questions. I wanted to talk to everyone a little bit about some recent stories in the news, just to point out that this is not a Karakalpakstan issue. And we don't live too terribly far from the Great Salt Lake, certainly closer than you all do. NPR's been doing a couple stories on this issue recently. The Great Salt Lake is drying up. And there's scientists who work in this area who are concerned about what that's going to mean in a couple different areas. The reason that it's drying up is because of water diversion, drought, and climate change. Those are the exact same 3 issues that have caused the Aral Sea to decrease in size so much. This is causing a lot of problems for migratory birds that tend to stop over the Great Salt Lake, so there's massive ecological consequences, conservation consequences. Researchers have pointed out that there are dusts in the bottom of the Salt Lake that contain microbes that people have never been exposed to, as well as heavy metals like mercury and arsenic. And so as this dust gets mobilized, what does that mean for human health? Dead Sea, very similar issue. Water diversion, drought, climate change, the Dead Sea is shrinking. You'll read about this in the Salton Sea in California as well. This is an issue we're seeing globally. And so working on this issue in Karakalpakstan benefits everybody. So again, we're going to meet with our partners next, go over these results, see if there's additional partners and expertise that we can engage, both in Karakalpakstan and outside of the country. And an important thing for us as a small nonprofit is we're really focused on the immediate and obtainable priorities that we can address. Doctors Without Borders and TIFO are not going to put water back in the Aral Sea, right? That's not something we're going to be able to figure out. But what is it that we can do to help those most vulnerable in the local population? And looking at some of those medium and long-term goals for that. So, the picture of the Caracal Pact flag on the left, that yellow stripe in it, and the Uzbek flag on the right, that's in the capital of Nukus. I wanted to end with just like a little plug. Because again, it wasn't that long ago that I was a student. So, thinking about these problems and the fact that I just showed you a lot of information about environmental sampling and public health systems and understanding epidemiology, right? These projects are amazingly complex. Agriculture, right? Economics. There's no shortage of amazing classes you all have available to you that you can take at this incredible institution. So I would encourage you to take every class you can, whichever one sounds interesting, because it applies in one way or another. I have a little plug in here too about rethinking environmental and climate justice. And I have that in there because we work on at a lot of sites impacted by climate change. And we also work with tribes within the United States, sovereign nations within the United States. And as much as we want to see climate change addressed, there are issues with some of the ways we're thinking about addressing them. And I always point this out to people when, and I know Ian and Margaret do too, thinking about the way that alternative energy still has an impact on the world. And the lithium batteries, especially, that come with those, they aren't without a cost. And there's a lithium mine going in next to one of the tribes that we work with. And so these problems, when you try and solve one, sometimes another one pops up. We always have to be thinking about that, trying to address it. As a Peace Corps volunteer, I would say you should leave the cornfield you grew up in and travel somewhere. And when you do, you don't teach, you listen. Right? We all have a lot to learn, and that's something we still try and do today, every day. If you ever want to do something with TIFO, please reach out. We have great connections with students at a lot of universities. Brock here, he is a University of Idaho graduate. He was a senior when he came with us to Caracal Pakistan last spring. He actually almost missed his didn't miss it, but almost missed his graduation to come. We love working with students. Often it's a desk research project. Sometimes it ends up being a field project as well. So you can learn more about that by reaching out to us. And of course, you can always follow and share stories and tell people about these issues and what we can do to solve them, because they're very solvable problems, especially with folks like you. So with that, if anybody has questions, comments, I think I flew through that kind of fast, but I wanted to make sure.
So firstly, thank you. That was really
Yeah,
great.
absolutely. Yeah.
I mean, I know you're not going to go in with a preset manual recommendations. That's not your style. I know it's iterative, but I also suspect you have a list of stuff you'd like to see.
Yep.
So what's on that list?
Pretty high on that list is partnering with a local research institution to be able to develop a more comprehensive long-term study of what some of those chemical risks are and salt risks are. Really high on that list too is building capacity within that local health institution to have better data management. Not management, but to digitize their database so that then they and the university in Caracal Pakistan can work together and students and researchers can analyze that and figure out where some of these issues are more prevalent than others. Those are two big ones, I think, for Ian and I both. And then pulling in other partners for things like provision of clean water supply. So we're talking to some folks at EPA and USGS who are going with us when we go in October, and thinking about ways that federal government agencies might be able to engage in some development kind of projects.
Are deep wells a solution?
Deep wells are tricky because the aquifer is saline. It is a saline aquifer.
It comes from the same mountains.
Yeah, and even though it's 400 to 1,000 feet deep, it's still salt water down there. So you can put a well in, but then you have to have a desalinization outfit. And they get blocked up really quick. I actually, well, I have some photos, but some of them that were put in about 10 years ago are defunct now because they don't have the filters for them and they get jammed up and they stop working. So it's got to be some forethought into it. But yeah, wells are an option. They just cost a little more than they would here. Other questions? Yeah.
Do you have any obstacles when you're initially working in Uzbekistan with the government?
You know, we are really fortunate to work so closely with Doctors Without Borders, and because they've been working there for so long, they already have incredible relationships and trust built with Ministry of Health and with communities. And so we're able to kind of go in on those coattails, and they introduce us, and they make, you know, we are their partners and the Ministry of Health's partners. But without that, there would absolutely be issues, right? You can't just go into a place and say, well, I'm here to study your water problem, you know? It takes years. We work in Kyrgyzstan as well, and we started working there in 2016. We didn't collect our first sample until 2019. It took us 3 years to build that level of trust. It's a good question. Other questions? Yeah.
What was your experience in the Peace Corps?
Yeah. So I was in a tiny little village in Lesotho, in Ramabanta, in Lesotho, and like many folks who go into Peace Corps, and it's changed quite a bit in terms of the application process, but I went in and I was told that there was this institution that wanted this work done, and I got there and it was like, well, that would take me about a day a month to do that project, so I had a lot of freedom to design my own job, which of course takes time, because you can't just go into a place and say, well, I know a lot about this, and so I'm just going to do this for the next 2 years. You got to see what the community needs and priorities and interests are, and so I spent a lot of time doing that and learning and doing cultural exchange, and I think every volunteer will tell you, unless maybe it's an English teacher, you know, who has something to do every day, you just spend a lot of time learning a lot about people, learning a lot about yourself, and it changed my life. I landed in Ian's office a couple months after I came out of Peace Corps. And I don't know, they might have hired me if I hadn't done that, but they might not have. So it's absolutely a life-changing experience, and I highly recommend it. If you ever want to chat about it, let me know. Yeah.
Do you see any willingness on the part of donors to get involved? I mean, in theory, these are the kinds of problems the World Bank is supposed to be dealing with, that the U.S. Agency for International Development is supposed to be dealing with. I can't say my knowledge is terribly deep, but my sense is that these countries are not, this part of the world is not a focus of a lot of development assistance efforts.
Yeah, it's a great question. There are some development assistance efforts in Central Asia, and they're increasing now with some of the concerns about Russian influence on former Soviet Union countries, so the things are changing. But it does feel like you're at the end of the world there and it's been forgotten. I mean, when you're out there in Moynak, it doesn't feel like anybody else is paying attention. There are absolutely development projects to be done, like provision of clean drinking water, right? Doing some more robust monitoring of air pollution issues and supporting some government efforts that way. There are some reforestation initiatives that have been done, mostly with the UN, trying to get some salt-tolerant plants, desert-tolerant plants to grow and reduce some of the mobilization of dust. So there's been some efforts with limited success so far. I think if we get permission to share, when we get permission to share all the details of what we've done and the data, we hope to use that as a tool to advocate for some of those kinds of things.
Are the governments receptive to inputs from outside? From, say, multilateral donors?
I think so.
Donors?
Yeah, I think so. And I think that's a transition that people are still in the middle of. But my sense right now, a year into this, is that that's the case. Do you have a different feeling? Or Ian's been there with me. I left him in Nukus for 4 weeks when I went out sampling, so he's got a pretty good sense of the area as well.
It's opening up a lot.
Yeah.
5 years ago, your question would be an easy answer, no way in hell.
Yeah.
But now with the new president, a lot of other geopolitical concerns here, they live on cotton. Their whole world is cotton. All their money comes from cotton. And they've been banned on the world cotton market for the last 15 years or so, because most of the cotton is picked by children. School children, we let children out of school for a month every year to pick cotton. We're from Idaho. I used to do that with potatoes when I was growing up.
but not under those kinds of conditions. So that they have, they've just gotten their cotton, ability to sell cotton on the world market, which means China doesn't suck it all up, so that helps open them up as well.
Is China moving in?
China's there always.
All over Central Asia, most
All of Central Asia sits between China and Russia, and alternate who's going to exploit it the most at this point. So all of those issues overplay. The Aral Sea didn't really start to dry up until independence because the Soviets used to control all the flow. Now it's a huge fight between the different republics who will take the water. So that's exacerbated. So there are all kinds of geopolitical influences, and you have to steer between those, of which we know nothing.
Yeah.
But Doctors Without Borders knows all those things, so
Yeah.
they're able to negotiate our access.
Yep. And that's why it's so important.
And they have a wonderful relationship with the government.
Yep, that's why it's so important we work with the government as much as possible to make sure that when we do have all the results finalized, they're the ones who determine how and when and who they get released to.
Yeah, I think it's important to point out that we collect data for the government. And the government can never show it to anybody if they don't want to. So just the fact that we're allowed to talk about it is an indication of how open it is. Frankly, they're not allowed as yet to just show you the actual numbers. But if it becomes beneficial to the government to show those numbers, so that helps attract someone to help solve these problems, then yeah, it'll open up more.
Absolutely. Yeah.
I was really interested in the soil samples at the school.
Yeah.
Are you able to, I don't know if this is feasible, but consider following those students prospectively once you get that lab sample back?
That would be fantastic. That's probably a couple steps into the future, that kind of thing. Right now, very preliminary, just trying to figure out what kinds of things we want to follow, right? And try and figure out from there what those next big research projects would be. But that would definitely be one. So we're doing some biological monitoring, right? And figuring out what is actually in kids' blood. So it would be a fantastic research project for a PhD student in the future.
Do people move around a lot in that country, or do they tend to stay in one place?
Excellent question. There's a lot of labor migration in Central Asia in general. A lot of people.
How about kids?
Not kids so much. So typically what happens is people will go to usually Russia, sometimes Turkey, for work, and send money back home and then come back home and raise their families. So typically kids stay. Yeah.
So we're up to the hour.
Oh, yeah.
And I want to be respectful of people's time. Does anybody take like one or two last questions? But then we should probably break it up.
And then I'll put my email address up here. You guys are welcome to email anytime. We love to work with students. And so definitely shoot us a message and let us know if you want to just connect or if you have more questions or that kind of thing.
And there's an enormous amount of pizza back there.
There's an enormous
I
amount of
see
pizza
two-
left.
If my eyes are not deceiving me, I see two entire untouched pies, so if somebody's got some roommates.
Yeah, you're
So thank you so much, Casey.
well,
This is
thank you
great.
again. This has been a lot of fun. Thanks, everybody.